It does. Yep. Okay, inverse trigonometric functions. Now, one thing about sine, cosine, and tangent is their inverses are not functions. Okay? Why are they not functions? Okay, they fail the horizontal line test because they're periodic functions. They go on forever, so they will fail the horizontal line test. So what we have to do for inverses then is that we have to restrict the domain so that we can find inverses. What's that? Right, we don't do inverses of them. Only sine, cosine, and tangent. We don't need it for the other ones. We don't need inverses for the other three because everything we do, we can use sine, cosine, and tangent for.
I think he's asking whether or not cotangent is the inverse of tangent.
No, they're not. They're reciprocals. They're not inverses. Okay? All right. Question is, are secant, cosecant, cotangent inverses of sine, cosine, and tangent? And they're not. They're reciprocals. There's a difference. 1 over it versus to the negative 1 power. Okay? Because of the inverse. Right? All right. The restricted sine function, f of x equals sine of x, is when the domain is restricted to the interval from negative pi over 2 to pi over 2. So when we're talking about restricting sine, we're talking about on the unit circle then, we're talking about the fourth quadrant and the first quadrant. So inverse sine, all right? You may see it a couple of different ways. That they might use sine negative 1 of x, which means the inverse sine. Also, as you're getting more advanced, you will also see this terminology, which they call it arc sine of x. Okay? And they mean the same thing. If you see arc sine, arc cosine, arc tangent, those are just the same as the inverses. Okay? I think because if they're talking about radians, and radians are a measure of an arc, okay, that could be why. In reality, I don't know. Okay, all right, thank you. It sings. Okay. Where is it? Minute special.
That's the best. Where do you get it? Where did you get that?
Oh, I think this was a Walgreens special. It was a while ago. No lights. Rudolph Nose does not light up.
Whole song.
Okay, so when we're talking about inverse sine, because the function sine does not have an inverse, we have to restrict it so that we have both positive and negative values for our domain. So because the inverse sine, the value of v in this case, has to be between negative 1 and 1, the domain, because on our unit circle, the y values only go from negative 1 to 1. Inverse sine is a unique number in the interval from negative pi over 2 to pi over 2. The reason why, because I need positive and negative. So for sine is, if we look at all of our stuff here for just a second, here's cosine, sine, and tangent. Cosine, sine, and tangent. Cosine, sine, tangent. Cosine, sine, and tangent. So for sine, we have to be able to restrict it so that we have an interval that we can use. And if I went from 0 to pi with it, we have both positive values there, so it wouldn't do us any good. So when we're working from we're going to do the fourth quadrant and the first quadrant from negative pi over 2 to pi over 2. So you're going to need to make sure that you take your unit circle and you're going to want to renumber the fourth quadrant, okay, so that you have negative angles there. Remember, if we go clockwise, we're talking about negative angles. So it's going to be the same angles I have as in the first quadrant. It's just they're going to be negative, okay? So 11 pi over 6 would be negative pi over 6. 7 pi over 4 would be negative pi over 4. 300 degrees would be negative 60 degrees. Okay? And the reason that we use that area there is because it does give us negative to positive. But if you look at the graph of sine, so let's look at the graph of sine. Is it up here? Okay. Here's part of the graph of sine from negative pi over 2 to pi over 2. If we continued this graph, it would come down here, and do I have a function anymore? No, the inverse would not be a function then because it would fail the horizontal line test. So we use this area from negative pi over 2 to pi over 2 for inverse sine. So if they ever ask you for the inverse sine of some number, you have to have an answer in there. If it's a negative value, then it would be in the fourth quadrant, those negative answers, negative 30, negative 60, negative 45. If it's positive, it's just going to be the ones in the first quadrant. Cosine. Cosine then, if you look at the graph of cosine, from, if we focused on that between negative pi over 2 and pi over 2, it would not be, the inverse would not be a function. So we have to restrict that. The restriction of cosine then is from 0 to 180, because in the first quadrant we have our positive values we need. In the second quadrant we have our negative values. And the thing is, with your calculator will find the correct answers. Still, our domain, we're only going to go from negative 1 to 1, okay, because that's all what our range is for cosine. But our interval we're going to be working with is from 0 to pi with cosine. So we're talking about the top half of the graph, because the top half of the unit circle, we've got in the first quadrant, cosine's positive. In the second quadrant, cosine's negative. We have a continuous graph there that we're going to work with. Tangent. Right? For tangent, it's going to be from negative pi over 2 to pi over 2 also. The one difference is that tangent, what happens with our graph? Goes from negative infinity to positive infinity, right? Okay. So tangent could be all real numbers. Okay. We could take the inverse tangent of any number. But we're going to do from negative pi over 2 to pi over 2. Difference is, notice, here I have parentheses versus with sine, it was brackets. What's the difference? Okay, why isn't pi over 2 included? It's undefined. Okay, so with sine and cosine, they're included because we have zeros in there. Okay, but tangent at the pi over 2's is not. Tangent in the fourth quadrant is negative. Tangent in the first quadrant is positive. Now the question is, why don't we use the first and second quadrant for tangent? Why not from 0 to pi? Because we have positive values in the first quadrant for tangent, negative values in the second quadrant for tangent, but it's not continuous because at pi over 2, tangent is undefined. And we want to make sure we have an area where the function is continuous. So we're using from negative pi over 2 to pi over 2 there. So if we kind of look at them graphically, inverse sine of x, my answers are going to be angles from negative pi over 2 to pi over 2. Fourth quadrant, first quadrant. For inverse cosine, first and second quadrants. Inverse tangent, fourth and first. So we're talking about inverses once again. So that means that if I have the sine of theta equals some number a, okay, Here I'm doing the sine of an angle, I get a ratio. When we're doing inverses, I have the inverse sine of the ratio gives me an angle. Right? So remember, we're switching x and y, switching the domain and range when we do inverses. So when we do sine of an angle, we get a ratio. When we do the inverse sine of a ratio, then we're going to get an angle. That's theta. So when we're talking about sine of theta, theta can be all real numbers. And then a for sine and cosine can only be between -1 and 1. For tangent, it could be all real numbers. When we're talking about inverses, okay, a here can only be from -1 to 1 for sine and cosine. Theta then is going to be one of my answers here from inverse cosine, inverse sine. Okay. So number 1, they want us to evaluate the inverse sine square root of 3 over 2. Since it's inverse sine, that means my answer must be between -pi/2 and pi/2. So if I look at the fourth quadrant and the first quadrant here, sine is positive in which one of those two quadrants? The first, okay? And where does it equal square root of 3 over 2? We're talking about radians. Pi over, talking about sine, the y values. Okay? All right. Okay. That's it. Okay? Yeah. Okay. Now, there's a difference. Let me explain the difference that you're going to be looking at compared to what your friends in Algebra C are going to be looking at. Okay? Now, when we did this in Algebra C, we talked about it 2 different ways. We said that if we use the lowercase, in Algebra C, we said if we use lowercase, we were actually trying to find all solutions, okay? So you'd have to do the plus 2 pi n, okay? And if we use the uppercase, then we said that's the restriction here, okay? The difference now in pre-calc is we're either going to be solving equations or we're not, okay? So when it says inverse sine square root of 3 over 2, we're just looking for that number in that range. If I want all possible values, then I would say, when does sine of x equal square root of 3 over 2? Okay. This would say find all possible values of x, where this one here just says find that number. Okay.
What's the sine of x? It's just pi over 3 and maybe 11 pi over 6.
It's not 11 pi over 6. Because 11 pi over 6 is not between -pi/2 and pi/2. Okay? All right, letter B. Inverse sine -1. Sine is negative in which quadrant? The fourth. Okay? And -1 is at what angle there? Okay? -pi/2. Okay? All right? Sine is equal to -1 right here, correct? Okay? But we're going from -pi/2 to pi/2, not from 3 pi/2 to pi/2. Because let's think about numbering for a moment. All right? Can I go from 360 to 1? Or do I go from 360 to 361? Okay? So if you are trying to use these numbers here for your answers for the fourth quadrant, that's incorrect because I can't use these then for the first quadrant then. Because that doesn't follow, right? We have to go in numerical order there for them to follow. So you have to make sure that you have it. So in the fourth quadrant, I have the negative angles there. Okay? Because we're looking at Oh, where's that? We're looking at this graph here, which goes from negative pi over 2 to pi over 2. So all of the negative values for sine are in the fourth quadrant, but they're negative. So negative 30, negative 45, negative 60, and so on. Okay? So my answer here is negative pi over 2. Inverse cosine, we're on number 3, okay? So our numbering, we're doing the odd numbered ones, okay, today. And then we're going to do the even numbered ones tomorrow. Or wait a minute. No, we're going to do them today too. Sorry. Never mind. Okay, but I'm working on the odd ones right at the moment. Okay, number 3. It says inverse cosine. That means we're working between 0 and pi. So I'm looking at the first and second quadrants. When does cosine equal 1? Is 2 pi between 0 and pi? No, but 0 is. Inverse cosine of 1 is 0. It's that right on the x-axis, right? Okay. Inverse cosine negative square root of 2 over 2. Is cosine negative in the first or second quadrant? Second, okay, so where is x negative square root of 2 over 2 in the second quadrant? What angle? Okay, so this is 3 pi over 4. Letter C, inverse cosine of 0.14. Is 0.14 on your unit circle? No, so how do I find the angle then? Calculator. My calculator must be in radians. So check our mode. Mine is in degrees. I better change it. Okay? And you can see I was actually working with this first hour. Okay? And I'll be doing that next hour. They're going to love me too. All right? Inverse cosine 0.14. 1.43. That's your answer. So let's think about this just for a second. Okay? If I have except that your calculator is not going to say 3 pi over 4. Okay, it's going to give you a decimal number. Now I want you to think about something for a minute. Okay. Now, when we're in radians, you need to understand this. This is 0 radians, correct? This is pi over 2, right? Here's pi. But now let's start talking about numbers. Okay, I know what those things are, but what are the numbers? This is 3.14, correct? Okay. This is 1.57. So if I do the inverse cosine of a negative number, all right, so for instance, letter B, then I should get a number between 1.57 and 3.14. Okay, so take your calculator and do the inverse cosine of negative square root of 2 over 2. And find that decimal number. Don't forget the negative. Okay, and now, where did that come from? Now, do 3 times pi divided by 4 on your calculator. Probably. And then do 3 times pi divided by 4, and you should have the same number, right? Okay, but what'd you get? 1 point what? Okay, 2.356? Okay, all right. So that number should be halfway between these two, right? Halfway between 1.57 and 3.14 should be that number because 3 pi over 4 is right there. Right? So it should be halfway between it. So now let's go back here to the inverse cosine of 0.14. The distance from here to here is how much? It's 1, correct? Okay, this distance, this point right here, this is the point 1, 0. So if cosine refers to x, doesn't it? So if I'm only going 0.14, that's only about this far, isn't it? 1/10 of the way there. Which means then if I'm going to hit my unit circle, I'm hitting the unit circle about at this point here, correct? So the answer I get for cosine of 0.14 should be just a little bit less than 1.57. And the answer we got was 1.43. So this should make sense that it's that number or close to that number. Okay? Because since I'm only going 0.14 of the way horizontally, if I drew the triangle that matched that, oops, not that. If I drew this triangle here, it would be like that, which means I'd have this angle, which is almost pi over 2, okay? A little bit less than that. So that number should make sense to you mathematically, okay? It's not just some number that pops up, okay? I want you to understand where it comes from and why it's there. Right? Now, all it has to do with coordinates. Because remember, negative square root 2 over 2, okay? That's going to go out here so that both x and y are the same in that case. Okay, let's look at tangent. Number 5. Okay, tangent, my answers have to be between negative pi over 2 and pi over 2. So if it's negative, we're talking about the fourth quadrant. If it's positive, we're talking about the first quadrant. Okay, inverse tangent, negative 1. Okay, it's negative, so it's got to be in the fourth quadrant. Where's tangent negative in the fourth quadrant? Negative pi over 4. Okay, it's coterminal with 7 pi over 4, but it's not. It has to be between 0 and negative pi over 2, so it's at negative pi over 4. Okay. That's one of the things that you need to understand. It's coterminal there, but it isn't that number. All right. Inverse tangent of negative 14. Negative 14 is not in my unit circle, so that means I have to actually do that on the calculator. And we do it on the calculator, and you will get negative 1.5, basically. That's almost on the y-axis then, isn't it? Because negative 1.57 is pi over 2. So that means that when I take y divided by x there, I'm going to get negative 14. So that means the y value is going to be much bigger than the x value in that case. All right. Okay. All right, let's look at the even ones then. 2, 4, and 6. So here's information that goes with those inverses. Okay. We add a little bit to this. This is doing, what do we call this? When we do inverse sine of sine, or the sine of the inverse sine. Quantum physics. No, but we did stuff like that back when we were doing inverses with our logarithms and our exponentials. Anybody remember what it is, Emily? Yeah. Yep. Composite functions. And if you remember when we did composite functions, that if we did a composite function of a function and its inverse, if they were truly inverses of each other, it equaled x. And so the inverse sine of u should equal u. The sine of the inverse sine of v should equal v. But notice there's some restrictions on u and v because you can only do when you do the inverse of sine, you have to get a number between negative pi over 2 and pi over 2. If you do the inverse of cosine, you must have a number between 0 and pi. Okay? So those things, you have to pay attention to those specifics there when we're doing the composites of sine and cosine and tangents. Okay. So number 2, we want to explain why the inverse sine of pi over 4 is pi over 4, but the inverse sine of 7 pi over 4 is not 7 pi over 4. Did I give you guys note cards for chapter 8? Did I give them to anybody then? Okay. So, why? Anybody know why? With pi over 4 it's true, but 7 pi over 4 it's not? Right, it's not in the restricted area. So 7 pi over 4 is not between negative pi over 2 and pi over 2. So that one would not be true because, and let's actually look at it numerically and see what it is. Yes. Yes, you didn't get one yesterday because you weren't here. Who else wasn't here? Oh, Max. There you go. Okay, so, all right, so here's how we do this because you're going to have to do some of these anyways. So we have, what's the sine of pi over 4? So we're going to work from the middle out, which we talked about that when we did composite functions. Okay? So we get the inverse sine of square root of 2 over 2. And what is the inverse sine of square root of 2 over 2? Pi over 4. Okay? That's why that's a true statement. Okay? Now, let's look at the other one. Okay? The sine of pi over 4 is square root of 2 over 2. So then the inverse sine of square root of 2 over 2 is pi over 4 because it has to be from negative pi over 2 to pi over 2. Inverse sine is restricted to be between negative pi over 2 and pi over 2. Okay? So when I do the other part of this, the sine of 7 pi over 4 is equal to what? Negative. Okay? So we're going to do the inverse sine of negative square root of 2 over 2. So since it's sine of the inverse sine, that means this answer has to be between negative pi over 2 and pi over 2, which 7 pi over 4 is not between them. So this is the answer. Okay? So that's why this is not true, because 7 pi over 4 is not between negative pi over 2 and pi over 2. Okay. Yes. Yep. And actually, you could say that right away. Okay. Yep. Okay. Number 4. And I've added a 4a to our problem. Okay. Number 4. They want us to find the cosine of the inverse sine of v. Okay. Now, the problem is that, what's v? Okay. Now, so here's what we have to do, is we can actually find this out because we have the ability to, I don't know, make a right triangle. So here's my angle theta, wherever I want it to be. Okay. And this part here says inverse sine of v. Well, sine's equal to what? Opposite over hypotenuse, right?
Yeah.
So that means that v is the opposite side, and what would be the hypotenuse then? 1. Now, here's the thing. Whenever we have values that are not on our unit circle, a place where we can actually find them, then we actually have to use triangles to do it. We understand that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this case, because they want us to find an angle, okay, because when we're trying to find inverse, okay, we're trying to find an angle. Well, that means then this implies that sine of theta is equal to v over 1, which is the opposite over the hypotenuse. And so I can use that information to build a right triangle so that I can find the adjacent side. And if I knew two sides of a right triangle, how do I find the third side of a right triangle? With the Pythagorean theorem. So that means that a squared plus b squared equals c squared. And so we're going to use the Pythagorean theorem to find the value of the adjacent side.
Do you get b over 1?
Well, if I have a number by itself, it's always over 1, right? Okay, I need a fraction because I need to have the opposite and I need to have the hypotenuse. Okay, if I gave you 3, then you would assume that's 3 over 1, correct? So if I give you anything, then as a fraction, it's that thing over 1. So we have v squared plus b squared equals 1 squared. So b squared equals 1 minus v squared. So b is the square root of that. And it's always positive.
What does square root?
You're not doing plus or minus because we're talking about the length of a triangle, side of a triangle. Okay. Okay. So to find cosine then, we're doing the cosine of this angle theta. And cosine of theta is equal to square root of 1 minus v squared over 1, which is just the square root of 1 minus v squared. And that's the answer. Okay. So what I'm going to do is I've set up a 4a here, okay, is we're going to look at this with a number that we know, okay? So maybe that'll help make a little bit more sense to it. Okay. So here I have the sine inverse cosine of 1/2. Now, let's take the unit circle just for a moment and find the answer. Okay? Inverse cosine of 1/2. Where does cosine equal 1/2 between 0 and pi? Okay, at pi over 3. Okay, and the sine of pi over 3 is equal to what? Square root of 3 over 2. Okay, so our answer here is square root of 3 over 2, because inverse cosine of 1/2 is pi over 3, and the sine of pi over 3 is square root of 3 over 2. Okay, so let's use a triangle to prove that. Okay. So they tell us the inverse cosine of 1/2. So that means, according to whatever angle I have, doesn't matter, the adjacent side has to be 1, and the hypotenuse is 2. And if we do the Pythagorean theorem with an adjacent side of 1 and a hypotenuse of 2, we'll find that the opposite side, or the third side of the triangle, is square root of 3. Is that true? Okay, mathematically it's correct. So if this is my angle then, theta, the sine then for that angle would be the opposite over the hypotenuse, square root of 3 over 2. Okay. And so using the triangle, whether it's ugly like this with the variables, or whether it's one we actually are used to using, okay, it still works out to be the same, the correct answer, either way. Okay. All right, so let's look at number 6 then, and then we'll be done. It says the sine of the inverse tangent of 1/2. Does tangent equal 1/2 on your unit circle? No, it doesn't. So my only option is then to draw a triangle, a right triangle. Okay. Theoretically, let's check it when we're done. All right, so this says inverse tangent of 1/2, right? So if my angle theta is here, where's the 1/2 go? Tangent is what? Opposite over adjacent. So the 1 is the opposite side, 2 is the adjacent side, which means then the hypotenuse is what? Four plus 1 is 5. Square root of 5. Okay? All right. So then the sine of theta is equal to opposite over hypotenuse, which is 1 over the square root of 5, or square root of 5 over 5. Well, guess what? Your calculator will not tell you that exact value. Okay? The only other thing and last thing is this, okay? If they give you a negative, you need to make sure you draw the triangle in the correct quadrant. Okay? For example, if this said inverse tangent of negative 1/2. Okay? Tangent's negative in which quadrant? Inverse tangent is negative in which quadrant? The fourth quadrant. So that means that the triangle I have would be in the fourth quadrant. And when we do opposite over adjacent, the opposite has to be negative because I have to go down for my y value and to the right for my x value to get there. Okay? Which means then if I'm dealing with sine still, my answer is going to be negative. If I'm dealing with cosine, my answer is going to be positive. Okay? A lot of stuff to think about.